Hey guys, today what we're going to be looking at is 3.1e, graphing with standard form. So as a quick reminder, you guys just took notes that standard form is ax plus by equals c. Remember, the only reason why we use standard form is to find 2 points, and that is the x and the y intercept. So it says find the x and the y intercept of the given equation in standard form. So this equation is ax plus by equals c, and I want to find the x and y intercept. We kind of already talked about this, but what we want to do is just a quick review. What we're going to do is we're going to have this equation, and I'm going to solve it twice. One time is when I'm going to find the x-intercept, and the other one is when I find the y-intercept. Now remember, on an x-intercept, my y value is always 0, and I am solving for x. Vice versa, on a y-intercept, my x value is always 0, and I am solving for a y value. So mathematically what this looks like is, in blue, I'm going to solve for the x-intercept first. So here's my equation, and instead of having x minus 3y equals 15, on an x-intercept, my y value is actually 0, so I'm going to plug in 0 for y. So I'm going to have x minus 3 times 0 is just 0 equals 15. And then x minus 0 is just x, and I'm left with x equals 15. That means when I plugged in 0 for my y value, my x value is 15. Therefore, my x-intercept is positive 15. Now in red, I'm going to do the same thing, except I'm going to solve for my y-intercept. Now on the point, as a reminder, your y-intercept is, your x value on a y-intercept is 0. So that's going to look like 0 minus 3y is equal to 15. This will give me negative 3y is equal to 15. And if I divide both sides by negative 3, I'm going to get a y value that is negative 5. Therefore, when I plugged in 0 for x, my y value was negative 5. So the y-intercept would be 0, negative 5. Alright, let's go ahead and look at the next one. So on this one, same idea. What we want to do is find the x and the y-intercept. And how we do this is we always set up 2 equations. One where we find the x-intercept. Remember, x-intercept is when I plug in 0 for y, and what is my x value. And the second one is when I find my x-intercept when I plug in my y-intercept when I plug in 0 for x and I figure out that number for y. So in red, let's go ahead and figure out my x-intercept, which is when I plug in 0 for y. This will look like 4x plus 8 times 0 is equal to 12. 8 times 0 is just 0, and 4x plus 0 is 4x equals 12. Then I'll divide both sides by 4 to get x is equal to 3. So therefore, when I plugged in 0 for y, I got an answer of 3. One thing I want you to start to notice is whatever number you plug in for, whatever variable you plug in 0 for, kind of just disappears. So you're left with just 4x, and that 8 times 0 disappears. Vice versa, in blue, let's go ahead and find the y-intercept now. This is going to be 4 times 0 plus 8y is equal to 12. That's going to be canceled. I'm left with just 8y equals 12. And when I divide both sides by 8, this will give me y equals 12 over 8, which is the same as 3 over 2. So therefore, when I plugged in 0 for x, I got 3 over 2, or 1.5 for my answer. Alright, now this one is a tricky one. Remember, whenever it is y equals, that's going to be a horizontal line. So what that is if I have a x and a y axis, so here is my y, here is my x, y equals 8 would go up 1, 2, 3, 4, 5, 6, 7, 8, and it would be a horizontal line going like this, and it would go through my 8. So what you want to do is find your x and your y axis. So the shortcut here is when it's just y equals, this orange line does not cross my x-axis, so therefore there is no x-intercept. There is none. But this point right here is 0, 8. That is a y-intercept. My y-intercept is 0, 8. So all you need to do is take, when it's y equals, it has a y-intercept and whatever that value is. Let's go ahead and look at another example of this. This is the same type of example, except instead of y equals, it's going to be an x equals. This is one of those special case scenarios. So a rough sketch of this graph would be, you would go down all the way on your x-axis to negative 12. So this would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this value right here for my x value is negative 12, 0. That means I would have a vertical line going up and down on x equals 12. As a quick reminder, when it's x equals, you will always have a vertical line going up and down. This does have an x-intercept, which is negative 12, 0. But this purple line does not touch my y-axis, so there is none. There is no y-intercept. So those are our two special case scenarios. If you guys still have questions with those, please rewatch those or come and ask me on Friday, because those will be on your quiz. Alright, so it says state the x and the y-intercept for the given equation. And I want to graph this equation by plotting those 2 points. So let's start by first finding the x-intercept. So as a quick reminder, to find the x-intercept, we are going to plug in 0 for y. So this is going to be x minus 5 times 0 equals 10. And x minus 5 times 0 is 0 equals 10. Which will give me x is equal to 10. There's nothing more we need to do. So therefore that point is 10, 0. Now let's go ahead and look at this again. But instead of on a y-intercept, instead of having 0 for y, we're going to have 0 for x. So this will be 0 minus 5y equals 10. Then I'll have negative 5y is equal to 10. Then I'm going to divide both sides by negative 5. This will give me y is equal to negative 2. Which means the y-intercept is 0, negative 2. So now I have my x and y-intercept, and these 2 points, I can just plot them right here. So I have 0, negative 2. So 0, negative 2. This tells me to go left and right 0, but it's telling me to go down negative 2. 1, 2. It's my y-intercept. Then my x-intercept was 10, 0. Which means I go to my x-axis, I start at 0, 0, and I go over 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my point. And now I'm going to graph these 2 lines by just connecting the dots. And your line would look like this. So on standard form, there is no rise over run. There is no looking at it. You just solve for 2 points. You solve for your x and your y-axis. You only plot those 2 points, your x and your y-axis. And then you connect the dots. So, if we were to convert this slope into slope-intercept form, which means we need y by itself, let's see what would happen. First, I would minus x on both sides. This would give me negative 5y is equal to negative x plus 10. I would then divide each and every term by negative 5. This would give me y equals a negative divided by a negative is a positive, and x over 5 is equivalent to 1 over 5 times x. And then a positive divided by a negative is a negative. 10 divided by 5 is 2. So I have the equation y equals 1/5 x minus 2. It says, does the equation in slope-intercept form represent the same line? Let's go ahead and check this out. If I have the equation y equals 1/5 x minus 2, what that means is I'm going to have a y-intercept of negative 2. So I go down 1, 2. That is my y-intercept. That is good. And it says that I have a slope of 1/5, which means a rise over run of 1/5, which is a rise of 1 and an over of 5. 1, 2, 3, 4, 5. There's a point. If I did it again, up 1 over 1, 2, 3, 4, 5. So that also works. What I am showing you this on this letter, why I am doing this with letter D, are those 2 lines the same? Is x minus 5y equal 10? Does that create the same line as y equals 1/5 x minus 2? And the answer is yes, they are. Because they have the same slope and y-intercept. So even though they look differently, one is written in standard form, one is written into slope-intercept form, they will create the same equation, the same graph on a line, the same line on a graph, I should say. Remember, standard form helps us solve two and only 2 points, which is the x and the y-intercept, while slope-intercept form gives us the y-intercept and a slope. Alright, so it says directions. Same idea. State the x and the y-intercept of the given equation, and then we're going to graph it. So, to find the x-intercept, what we're going to do is plug in 0 for y. So that would look like 3x plus 2 times 0 is equal to negative 6. This would give me 3x is equal to negative 6. Divide both sides by 3 to get x equals negative 2. That means when I plugged in 0 for y, I got a negative 2 for my x value. Now let's go ahead and do the same thing for my y-intercept. Remember, on standard form, you're always going to have 2 equations. One where you plug in 0 for y, and then the second when you plug in 0 for x. So for a y-intercept, let's go ahead and plug in 0 for x. So 3 times 0 plus 2y equals negative 6. This will give me 2y is equal to negative 6. I'm going to divide both sides by 2 to get y equals negative 3. So therefore, when I plugged in 0 for y, or 0 for x, I got a y value of negative 3. Remember, standard form is used just to find your x and your y-intercept, so I have my 2 critical points. So now let's go ahead and graph these. I have negative 2, comma 0, which is my x-intercept, and 0, comma negative 3, which is my y-intercept. Now that I have my 2 points, I can go ahead and connect the 2 lines. And there you go. You already got your graph of a line. So it says convert this into slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So let's go ahead and get y all by itself. I would start by minusing 3x on both sides. This would give me 2y is equal to negative 3x minus 6. Then I would divide each and every term by 2. This would give me y equals negative 3 over 2x minus 3. So, does the equation in slope-intercept form represent the same line as 3x plus 2y equals negative 6? Well, let's find out. I got y equals negative 3 over 2x minus, minus 3. I'm all over the place here. Minus 3. Well, my y-intercept, I would go, this is my y-intercept, this is my b value. So on the graph, I would start at the origin and go down 1, 2, 3, and that's the same spot, so we're good there. It's the y-intercept, my b value. And then to get more points, I need to go down 3 over 2. So if I go down 1, 2, 3, and then over 1, 2, my line I drew a little crooked, but that should line up if I drew it correctly. So if I just rotate it just a tad, there we go. That's a little bit more better. So let's go and relook at that again. Starting at this point, if I did my slope of going down 3, 1, 2, 3, and to the right 2, down 1, 2, 3, to the right 2, those would land on each and every point. So, does the equation in the slope-intercept form represent the same line? Yes, because they have the same slope and y-intercept. Cool. Alright, let's go ahead and pause this video here. We only have one more pretty short video, so go ahead and stop it here and open up 3.2e Part 2.